Now we move on to travel time and delay studies. So basically, a travel time study identifies or it determines actually the amount of material that is required to travel from one point to another on a given route. So in conducting such a study, we gather information on a certain location, its specific duration, and the cost of delay. So basically, uh, we try if we're going to conduct travel time studies, so which means that we are trying to obtain information related regarding the location, the duration of the travel time, as well as the cost of delay. So basically, of course, when we travel, it's not as smooth as sailing travel. So there are some instances that there will be a delay as you travel from one point to the other. So when this study is being conducted, when this is being done, the study is known as travel time and delay study. So the data that is being obtained or the data obtained or gathered from travel time and delay studies give a good indication of the level of service on the study section. So basically, this data also aid the traffic engineer in identifying problem locations which may require special attention in order to improve the overall flow of traffic on the route. So what are the applications of the data gathered from travel time and delay studies? So basically, the data that is being gathered or obtained from our travel time and delay study can be used for the following traffic engineering task: determination of the efficiency of the route with respect to its ability to carry traffic, identification of the locations with relatively high delays and causes for those delays, performance of before and after studies to evaluate effectiveness of traffic operation improvements, determination of relative efficiency by a route by developing sufficiency ratings or congestion and indices, determination of travel times on specific link for use in trip assignment model, compilation of travel time data that may be used in trend studies to evaluate the changes in efficiency and level of service with time, performance of economic studies in the evaluation of traffic operation alternatives that reduce travel time. So basically, the data that is being gathered for travel time and delay study is basically for is used actually in overall, it's used to evaluate the effectiveness on how on the traffic operations improvement. So basically, the travel time and delay data that is being gathered or obtained will be an input for to improve the traffic operations, the traffic conditions of a certain location of a certain route on the section of the highway. So we have here some definitions of terms that is related to time and delay studies. So we have here travel time, which is the time taken by a vehicle to traverse a given section of a highway. We have the running time, that is actually the time a vehicle is actually in motion while traversing a given section of a highway. Delay, the most lost by a vehicle due to causes beyond the control of the driver. Operational delay, that is the part of the delay caused by the impedance of other traffic. Stop day delay, that is part of the delay during which the vehicle is at rest. Fixed delay, that is part of the delay caused by control devices such as traffic signal. And we have the travel time delay, that is the difference between the actual travel time and the travel time that will be obtained by assuming that the vehicle traverses the study section at an average speed equal to that for an uncongested traffic flow on the section being studied. So those are terms that is being used related to travel time and delay studies. So for the methods for conducting travel time and delay studies. So basically, there are methods that is being used to conduct travel time and delay studies. It is being grouped into two categories actually. Using a test, one is using a test vehicle, and number two, those that not require a test vehicle. So the methods that require a test vehicle we have here, floating car technique. So this floating car technique, actually, the car is driven by an observer along the test section so that the test car float with the traffic. So which means that the driver of the test vehicle attempts to pass as many vehicles as those that pass his test vehicle. So basically for this, we have here an equation to identify the sample size or the minimum number of test runs. So which has equivalent to quantity, value of students T, distribution, with 1 minus alpha all over 2 as the confidence level, and degrees of freedom is n minus 1. Multiply that one to our standard deviation sigma all over d, which is our limit of acceptable error in the speed estimate. Raise that to the second degree. So that is the formula for our sample size n. And basically, the limit of acceptable error used depends on the purpose of the study. So that is before and after studies, which is positive and negative 1.0 to positive and negative 3.0 mile per hour, traffic operation, economic evaluations, and trend analysis from positive to negative 2.0 to positive negative 4.0 mile per hour, highway needs and transportation planning studies, positive negative 3.0 to positive negative 5.0 mile per hour. So the average speed technique, so there's the second one. This is a technique which involves driving the test car along the length of the test section at a speed that, in the opinion of the driver, is the average speed of the traffic stream. The time required to traverse the test section is being noted. So in each of this method, it is first necessary to clearly identify the test section. So which means the way the travel time is usually obtained is that the observer starts a stopwatch at the beginning point of the test section and stops at the end. So we have here a sample for our speed and delay information taken from a certain location with a specific duration time during the travel. So we have here, this is this is table 4.8. So basically now the third one, we have the moving vehicle technique. The moving vehicle technique, this is a technique wherein the observer makes a round trip on a test section like the one shown in our figure 4.16. It is assumed that the road runs east to the west and the observers start collecting the relevant data at section x-x, which drives the car eastward to section y-y, then turns the vehicle around and drives westward to section x-x again. So we have here, this is the data that was collected as the vehicle makes a round trip. So we have here. And so basically this is the illustration for our test site for our moving vehicle. So we have here the movement of the vehicle, which is, as mentioned, it takes to travel from east, travel east from x to x, then you have to travel west from y to y and to x, and then we have the number of vehicles traveling west in the opposite lane while the car test is traveling northeast. And of course, we have to take note that the volume in the westbound direction can be obtained using this equation. So this is the equation that you're going to make use, wherein our n's of E plus O's of W minus P's of W, that is the number of vehicles which travels westward that cross the line x dash x during the time T's of E plus T's of W. And you have to know that the test vehicles start at x-x traveling eastward, or vehicles traveling westward should get to x-x before the test vehicle. So except those that are passed by the test vehicle when it is traveling westward. Similarly, or vehicles that pass the test vehicle when it is traveling westward will get to x-x before the test vehicle. And similarly, the average time T's of W in the westbound direction is obtained using this equation. So we have here bar T's of W is equal now to this equation. And you have to take note that this is if the test car is traveling at the average speed of all vehicles, it will most likely pass the same number of vehicles as the number of vehicles that overtake it. So for this one, you have to take note of the direction for our which refers to the variable that is present in our equation. So we have here a sample problem. The data in the table for point 9 were obtained in a travel time study on a section of a highway using a moving vehicle technique. Determine the travel time and volume in each direction at this section of the highway. So which means that we have here the mean time it takes to travel eastward, that is T sub E, is 2.85 minutes. The mean time it takes to travel westbound, T sub W, is equal to 3.0 minutes. Average number of vehicles traveling westward when test vehicle is traveling eastward, N sub E is equal to 79.50. Average number of vehicles traveling eastward when test vehicle is traveling westward, N sub W is 82.25. And the average number of vehicles that overtake test vehicle while it is traveling westward, O sub W is 1.25. So for that one, we have here the data from our travel time study using the moving vehicle technique. So we have here the corresponding run direction or number. We have the travel time. We have the number of vehicles traveling in opposite direction, the number of vehicles that overtook test vehicle, and the number of vehicles overtaken by the test vehicle. And we are given also with the average number of vehicles that overtake test vehicle while it is traveling eastward, O sub E, which is 1.0, and the average number of vehicles that test vehicle passes while traveling westward, P sub W, is 0.875. And the average number of vehicles the test vehicle passes while traveling eastward, P sub E, is equal to 1.5. So for our solution, we're going to find first the volume in the westbound direction. So from our equation, the volume in the westbound direction is given by this equation, V sub W, which equal to N sub E plus O sub W minus P sub W times 60 all over T sub E plus T sub W. So we have to take note, these are given in our problem. So simply have to substitute. So that is 79.50 plus 1.25 minus 0.875 times 60 all over T sub E and T sub W is given also in our problem, which is 2.85 and 3.07. So it gives us a value of 809.5, or that is 810 vehicle per hour. Now, similarly, we have to compute also the volume in the eastbound direction. So to compute the volume in the eastbound direction, so we have here V of E. So you simply have to substitute. This is actually equivalent to, this is our N sub W. This is N sub W. Then this one is O's of E. So we have the value for O's of E. Then this one is the 1.5 is P's of E. So times 60 all over T sub E plus T sub W. So 2.85 plus 3.05. When simplify, you have 828.5, or simply that is 829 vehicle per hour. So now we're going to get the average travel time in the westbound direction. So to get the average travel time in the westbound direction, so we simply have to make use of our equation. So our equation actually is, our equation here is T of W is equal to bar T of W to get the travel time in the westbound direction is equal to T of W minus 60 times O of W minus P of W all over V of W. So if we're going to simply substitute now, T of W is given our problem, which is 3.07. Our O of W is 1.25. Then our P of W is 0.87, 875 all over. V sub W, we have computed that one, which is 810 times 60, which give us 3.0 minutes.